This video is brought to you by myself, Red-Eye Jedi, and GE Challenge M, who I'll refer to as Gek for the rest of the video. You may know Gek from his God Wars guides and quest speedruns on YouTube. All of the technical information in this video comes from his research, and honestly, this video would not be possible without him. You'll find links to his channel in the description. In this video, we will be breaking down how boat movement works under the hood, and how it differs completely from player movement. We'll talk about speed, true quarter tile updates, and how sailing direction and rotation affect your actual travel distance per tick. This is where things get weird, and where Barracuda trial optimization really begins. We'll look at how Gek used classical AI techniques, specifically a heuristic search algorithm, to intelligently explore a massive solution space to find optimal paths in the Barracuda trials. I'll share my own speedrunning tips and tricks, including the routes I used to set world records on the swordfish, shark and marlin course, with a final time of 3 minutes and 57 seconds for marlin. I'll show how I broke out the beta, reaching the second and third Barracuda trial, with a mechanic not seen in the intended playable area of the beta. I'll also be sharing data mined info leaking all ship sizes, speeds, wind durations, and variables the engine tracks on your boat, and much more. Rare drops from salvaging, rewards from every Barracuda trial, what every facility does, and how you can protect yourself against dangerous waters. We'll cover a bug and an exploit discovered by Gek, one rounding error that was patched during the beta, and one still unpatched exploit known as the boat proxy discovered by Gek. Let's dive in head first with the difference between player movement and boat movement. There are spoilers throughout all of this video, and be aware that anything you see here may not be 100% representative of what you see on launch. When a player clicks to move, a destination tile is set, and once you reach that tile, you stop and become idle. For example, when travelling north-northeast according to your compass, you'll need to click in an L-shaped pattern each tick to maintain your path. Boats work different. They have perpetual movement with no set destination tile. When sailing, your boat continues to travel indefinitely in the direction you clicked until you decide to stop or change course. Clicking north-northwest, for example, makes the boat continuously move in that direction, effectively performing a repeating L-shaped path. Players move at 2 different speeds, and boats move at 8 different speeds, starting at 0.5 tiles per tick to a max speed of 4 tiles per tick. Some of you with a keen eye may have noticed the boat speed interface showed speeds incrementing in values of 64 during the sailing betas. A speed of 64 is equal to 0.5 tiles, and I have been told this interface will show true speed for release, so you will now see 0.5 and 1.0 speed on your interface, instead of 64 and 128 like the beta had. But why did it show values of 64? In the engine, a tile is defined as a 128 by 128 unit square. When it comes to sailing, things get a bit complex. Tiles at sea appear as though they've been subdivided into a 4x4 grid of 32 by 32 unit squares. But Jagex didn't actually remap the ocean into smaller tiles. Instead, the engine uses a clever trick. When you step onto your boat, your character is teleported far away from the main world map into what's called your boat instance. The boat instance is a static 8x8 tile area, or 8x16 for larger boats. Your boat is always facing south, with all of its contents, including yourself, fixed in this static area. Back in the main world, the engine draws a boat entity where your boat should be. This entity acts as a placeholder. It has a rectangular hitbox, and every frame, the boat instance is rendered at that entity's position. The center point of the entity is its logical position. It can lie at 0, 32, 64, or 96 units within a normal 128 by 128 tile. The boat entity can also rotate in 22.5 degree increments, though your instance itself doesn't rotate, only the rendering in the main world does. Here is a normal tile, and next to it we have a sailing tile. As you can see, we are now moving in quarter tile steps while sailing on our boat. At a speed of 0.5, This is how your boat's true quartile updates when travelling north, north-northeast and northeast. Let's take a look at all 8 speeds side by side. This is how your true quartile updates at every possible boat speed. Going back to a speed of 0.5, let's take a look at your true tile travelling in every direction for a total of 8 ticks. Here we can see when travelling at a 45-degree angle, so northeast, northwest, southeast and southwest, we are losing 0.59 quartiles of distance per tick, which is very noticeable when travelling in game. Travelling 22.5 degrees, so north-northeast for example, we are gaining 0.23 quartiles per tick. But why is this? Let's take a deeper look at what the engine is doing to calculate our movements. At 0.5 speed, the engine defines this as moving 64 units at 0 degrees north. When we move to 22.5 degrees north-northeast, the engine calculates a movement of 64 units at exactly that angle, which would ideally land us at the position marked by this red dot. However, the engine doesn't store positions as floating point values. Instead, it rounds the final position to the nearest point on its integer grid. In this case, the position snaps upward, giving us a slight gain of about 0.23 quartiles of extra distance. When we continue rotating to 45 degrees northeast, you can see that the nearest grid point now causes us to snap downward, resulting in a loss of 0.59 quartiles of distance. This rounding behaviour also affects our true angle of travel, meaning the actual direction we move in is slightly different from the intended one. While that difference isn't particularly useful in gameplay terms, it's a neat detail to note. It's worth mentioning that the true angles you are travelling and the distances lost and gained are different for every speed. For the best hull, being a rosewood hull, the relevant speeds are 3.5 and 4.0 tiles per tick. Understanding which angles are fastest for these speeds is important for optimising a world record within the Barracuda trials. Before we move on to the Barracuda trials, let's take a look at a really obscure rounding error bug discovered by Gek, which could only occur at a speed of 3 tiles per tick. When travelling diagonally at any 45-degree angle, your movement should be even. However, at this specific speed, something strange happens. Instead of moving evenly, one direction ends up faster than the others, that being northeast. Normally, movement is calculated in fine units, 128 per tile, then divided by 32 and rounded. The problem shows up when the result lands on exactly 0.5. The game always rounds up, even for negatives. So instead of the result being 9 and -9, which would be perfectly symmetric, it becomes +9 and -8, breaking the symmetry. This leads to you veering slightly north when moving northwest, veering slightly east when moving southeast, and stopping 1 quartile short when travelling southwest. This broke collision detection and led to players getting stuck in places they shouldn't have, and thanks to Gek giving Jagex the heads up, we managed to get this patched, and we now travel evenly in all directions at this speed. Finally, here is an infographic showing the boat speeds, wind durations, and hit points of all 21 boats you will have access to on launch. It also shows what upgrades you will need for each Barracuda trial, as well as additional HP and defences from building every kill. As you can see, you will need an adamant kill to gain crystal flecked resistance, gaining the ability to sail the crystal seas within the Glenif Glide. For fetid water resistance, you will need to build an inoculation station to handle the fetid waters around the Jubbly Jive. Let's dive into the Barracuda trials. Barracuda trials is a skilling activity unlocked at level 30 sailing. Gameplay involves navigating obstacles at sea, in which players must deliver rum and lost supplies to the Barracudas as quickly as possible. Each trial has 3 ranks of difficulty: swordfish, shark and marlin, each with increasingly strict time limits and collection requirements. The first completion of each tier awards bonus sailing experience and unlocks the ability to try the next tier. Your fastest completion time and ranks are tracked by the scoreboard. Playing currently is the 1 minute and 15 second swordfish world record set by myself during the beta. Upon completing the swordfish trial, you will be awarded with a stormy key. It appears to us that this key and the reward given for shark and marlin are 100% guaranteed upon beating the target time. All rewards from every trial, including the Jobbly Jive and Gwyneth Glide, will be revealed shortly. At the end of the run, we save 3 ticks on world record by exiting the boat and running to the front. 2 things are happening here. The rum is thrown from your player's position, not your boat's position, and moving to the front of the boat saves 1 tick on the throw. Through an accidental discovery, myself and Gek realised it was possible to save an additional 2 ticks, ending the timer instantly when the rum is thrown, instead of waiting for the projectile delay of the throw. The final box collected just so happens to be in a perfect spot to make this possible. Every time a crate is collected or rum is delivered, the game checks whether you meet the criteria for finishing the course. Your crate and rum counts go up instantly when they start flying, but the end of game check only happens when their animation finishes. So if you pick up the final crate and before its animation finishes you throw the final rum, the game ends instantly after the crate animation finishes, ignoring the rum throw animation completely, saving the additional 2 ticks. During the beta, Gek spent a lot of time figuring out the mechanics with the goal of writing a pathfinding AI to solve and produce an optimal path. I asked Gek why he did this and what his goals were with this, and this is what Gek had to say.
Hey, I'm G-Challenge-M, and one of my favorite things in old school RuneScape is doing niche speedruns. You know, the kind where the time saves are insanely hard to discover, but super satisfying and easy to execute once you figure them out. The Barracuda trials fit that description perfectly. Before you can even start optimizing though, you have to understand how the game actually works, in detail. Every little mechanic can be turned into a time save if you know what you're doing. So during the sailing alpha, I spent most of my time running tests, poking at everything, and figuring out what makes the system tick. By the time the alpha ended, I had a pretty solid understanding of the core mechanics. But I hadn't tested collision in detail, and that ended up being a big deal. Still, I managed to handcraft a surprisingly good route using just Microsoft Paint, drawing pixels. Yeah, not exactly high tech, but it worked. Of course, I knew there was no way that path was perfect. There are just too many variables. So I decided to write a pathfinder that could calculate the optimal path for me. Now I already knew I couldn't make it figure out the best crate order. That's basically the traveling salesman problem, one of the hardest problems in computer science. There is no known efficient solution for it, and finding one would literally earn you $1 million. So instead, I focused on finding the fastest route, given a specific crate order. My first attempt was an A-star pathfinder. It's a really solid algorithm. If your heuristic is good, it guarantees the optimal path. But even with a decent setup, my version would have taken literal years to finish. That's because the Barracuda trials are way more complex than they look. Your boat state isn't just position and angle, it's 10 different variables. You've got your X and Y coordinates, the angle of the boat, your current target crate, your stacked rapids boost count, the rapids you last sailed over, the time since you last sailed over those rapids, the time until the next wind boost is available, and the remaining wind boost time. So yeah, 10 dimensions. To speed things up, I tried making my heuristic a bit cheaty. Not perfectly accurate, but faster. And the problem? The results were actually worse than what Red Eye Jedi and I could manually do in Microsoft Paint. So the A-star ID was a dead end. Next, I moved to a beam search algorithm. The concept is simple, but powerful. You set a beam size, say 100,000 states. Each tick, the program simulates all possible actions. Turning, slowing down, using boosts, or even a combination of those. And then, it keeps only the 100,000 most promising options and repeats. Tick after tick, until you reach the finish. And yeah, this worked way better than A-star. Increase the beam size and the routes just keep improving. But then I hit a wall. my collision model was too simple. When I tried using a more accurate one, everything slowed down again. So during the sailing beta, I ran a bunch of new collision tests. Eventually I came up with a model that matched the in-game behavior almost perfectly, and I even found out that collision can help you. If you angle your boat just right, so the back clips slightly into an obstacle, the collision actually pushes you forward. That was huge. I couldn't wait to see my Pathfinder use that. After the beta, I dove back into the code. I implemented the proper collision mechanics, and yeah, it got painfully slow again. So I had to make it faster. A lot faster. That's where memorization came in. Basically, there are only so many ways collisions can happen. So instead of recalculating them every single time, I pre-computed them all at the start. Now the program just looks up the result instantly. That one change saves an absurd amount of time. Then I went all in on optimization. More memorization, parallel processing, better data structures, and even switching to a faster garbage collector, ZGC. The result? A massive speed up. I could now scale the beam size so high that my RAM became the bottleneck. And I had already bit-packed the boat state data to squeeze out every last byte. So I did something clever. Since beam search only needs the current beam, I dumped the old ones onto my SSD to free up RAM. Then, at the end, the program just loads them back to reconstruct the final path. In the end, I'm really happy with how it turned out. The maximum realistic beam size ended up being about 100 or even 1000 times larger than it was before. For the Swordfish course of Tempor Tantrum, I tested how the best route improved as I increased the beam size. It kept getting better until around 200,000, and after that, even going up to 20 million didn't improve it at all. So yeah, I think it's safe to say my Pathfinder actually found the optimal route.
With Gek hard at work on his AI optimizing the Swordfish trial, this left me plenty of time to make a route for the Marlin course. After many hours, I was able to produce a final time of 3 minutes and 57 seconds. This is by no means optimal, but is the current world record. I really enjoy the Barracuda trials. On a normal agility course, ignoring unique time saves, you can find an optimal route easily. Just click from obstacle to obstacle, and the pathing algorithm will draw the shortest path for your player. That doesn't work for a perpetual movement system like a boat. Between one tick and the next, the boat can enter one of 9 possible states. It can rotate left 22.5 degrees, it can rotate right 22.5 degrees, or continue straight. Combined with speed staying the same, increasing by 0.5 or decreasing by 0.5. If a course takes n ticks, the total number of unique possible paths is 9 to the power of n. For the Marlin course, that comes out to 9 to the power of 395. There are 10 to the power of 80 atoms in the observable universe, and 9 to the power of 395 is 10 to the power of 297 times larger than the total atoms in our observable universe. So a pathfinding AI could potentially have to sort through an amount of possibilities comparable to duplicating every atom by 10 to the power of 297. Imagine you take the observable universe and duplicate every atom one by one. Do this again 500 trillion times. The resulting number of atoms would still be vastly smaller than the state space of the Marlin trial. This number is unfathomable to comprehend. Many paths converge to the same line, so that can simplify it, while in these calculations we consider them as being different. This is the route I will be using on release, and I will be looking forward to future videos from Gek, pushing the limits of the trial. Let's talk about rewards from Shark and Marlin, as well as all the rewards from the Jubbly Jive and the Gwyneth Glide. From the Shark course, you will receive a barrel stand. A barrel stand is used to make a keg station on your ship, which stores various brews that can buff you and your crew's actions on your boat. From the Marlin course, you will receive Ralph's Fabric Roll. This is the mystery item needed to create flags and trims on your ship. The Jubbly Jive has 3 unique rewards. For Swordfish, you will receive a fetid key. The purpose of this key is unknown. For Shark, you will receive a captured wind mote. This is required to build a wind catcher on your ship. For Marlin, you will receive Gertob's fabric roll, another item needed to create flags and trims on your ship. The Gwyneth Glide's rewards follow a similar pattern. For Swordfish, you will receive a serrated key. The use for this is unknown. For Shark, you will receive the Heart of Ifhel. This is required to build the Crystal Extractor Facility on your ship. The Crystal Extractor Facility will periodically generate wind motes for a wind catching facility. The wind catcher can store a maximum of 2 winds, whilst the gale catcher can store a maximum of 3. When it comes to collision, I could sit here and talk about the fine details of collision, but ain't nobody got time for that. However, using collision to our advantage, we are able to do what me and Gek call a boat proxy. This is where your boat enters collision and gets pushed out, resulting in a boost of speed. This takes the maximum speed from 4.15, travelling 22.5 degrees, to 5.37 tiles in a tick, gaining 1.22 tiles of distance in a single proxy. For large boats, we can gain 1.56 tiles of distance in a single proxy, resulting in a max speed of 5.71 tiles over a single tick. So how do you perform a proxy, and why does it work? Whenever you turn, your boat is rotated 22.5 degrees and checks whether your boat's hitbox overlaps any squares that are blocked. If it does, the boat is pushed away 1/4 of a tile away at a time from the tiles that were collided with until the rotated boat doesn't overlap with any collision. This check is performed up to 5 times within the same tick, resulting in a maximum of 5 quarter tile pushes. In this image, we rotate the back of our boat into a 1x1 area of collision. The boat's hitbox intersects with the south and west edge of the collision. The engine will now push us in those directions away from the wall until we are no longer inside of the collision. Once out of the collision, we continue with our intended speed from the point we were pushed to, resulting in gaining the full distance of the push. All of this happens within a single tick, gaining 3 quarter tiles of movement or 0.7 tiles in the southwest direction in this specific case. During the beta, I found a way to break out. There was a wall blocking access to the rest of the map, but Jagex left a 1x1 gap perfect for the raft to enter. After breaking out, I was able to visit every island, as well as the 2nd and 3rd Barracuda trial. I managed to break onto land here and perform the world's first boat jump. Earlier in the video, I mentioned the 3 keys, one from each Barracuda trial had an unknown use. We have found that each Barracuda trial will award what appears to be a cosmetic outfit, and it is our assumption this is what each key will give you. Let's go over the rest of the facilities. The sonar and Fremenic sonar orbs appear to have been renamed to the Fathom Stone and Fathom Pearl. The Fathom Stone facility is capable of peering into the depths of the ocean, useful for detecting the rough location of nearby shoals at sea. The Fathom Pearl is the enhanced version, which can pinpoint the exact location of fish shoals. The Chum Spreader is a station that can be used to spread all types of fish offcuts into the sea while deep sea trawling. When doing so, it can take offcuts directly from your cargo hold. The Teleport Focus allows you to teleport your boat to the dock or mooring point you are currently at. The Greater Teleport Focus allows you to teleport your boat to the dock or mooring point you are currently at, as well as letting you teleport to where the boat is as well. The Anchor Facility allows you to drop an anchor to stop the boat, though we are unsure why this is needed, as you can manually stop your boat in the same amount of time. We can only speculate some areas of the sea may have a current to prevent you from stopping unless dropping an anchor. Let's go over the salvaging rares and the Sailor's Amulet. There are 8 total shipwreck types to salvage. There are 8 unique rares from turning in your salvage, and they are as follows: Rusty Locket, Mouldy Block, Dull Knife, Broken Compass, Rusty Coin, Broken Sextant, smashed mirror, and a mouldy doll. There are 8 fragments of the Sailor's Amulet. It is my assumption here that you need to turn the rares from the salvaging into an NPC, one from each shipwreck type, to receive each fragment piece to create the Sailor's Amulet. There are teleport locations on the amulet, though we are not 100% sure on the accuracy of this information. They are as follows: Port Roberts, the Pandemonium, and Deep Fin Point. There is also the Medallion of the Deep. We have no idea how to obtain this, but we do know that it allows the wearer to breathe underwater. In the game's files, Gek discovered 25 unique ground tiles, which clearly make up a puzzle. We can only speculate this puzzle is part of an upcoming quest. Gek put the tiles together to create this image, which may be the solution to a puzzle somewhere on release. If you have any questions about something in this video, or even not in this video, please ask in the comments. If I know the answer, I will answer it. If there is something that might help you with your sailing prep, just ask. I will leave you with the footage of me entering the 2nd and the 3rd Barracuda trial. During the 3rd trial, I discovered a new mechanic that freezes your navigation helm, requiring you to click it 3 times to break free, gaining a boost of speed. It is entirely speculation, but with this boost of speed, it may be possible to take the max speed of 4 to 4.5 tiles per tick, but currently we do not know if this is additional speed beyond the currently known cap. I really hope you enjoyed this video, and again, if you have any questions about anything, please ask down in the comments and I will get back to you. Link to the Google Doc from the start of the video will be in the description, and I think that's it. I'm done yapping. Enjoy the rest of the footage, and I will see you guys on the next one.